Good morning students. In this class we will be doing class 10 matriculation syllabus or Samachir Kalvi syllabus. We are doing first chapter relations and functions. So already 3 exercises I have completed. Now I am doing 4th exercise. So in 4th exercise few sums I have completed already. The remaining sums I will do now. Before doing those sums we will know about types of functions. So after knowing all these things, we will do the remaining exercise sums. Okay. So different types of functions are there in this. The different types of functions are one-to-one, one-to-one. 4 different types of functions are there. One-to-one, many-to-one, on-to, and into. So 4 different types of functions are there. Okay, so first one is one-to-one function. So if a function from A to B is defined as one-to-one function, then the distinct elements in A have distinct images in B. That is, if you take 2 sets A and B, when it is connected this with a function f, distinct elements, that is different elements in B have different images in B. So if for example if we take like this, so different elements in A have different images in B. So 1 to A, 2 to B, 3 to C and 4 to D. So this is called one-to-one function. So one element have one image on the other side. So different elements have different images on the other side. This is one-to-one function. Then many-to-one function is if a function f is defined from A to B and the given function is called many-to-one, that means 2 or more elements have same image in the next set. So if we take the set A and B, and here 1, 2, 3, 4, here A, B, C, D, 2 or more elements have the same image in the next set. So if A is connected with this with a function, 2 is also connected with this. So like this, we will get function. So 2 or more elements, like this you will get. So these 2 elements have the same image in the next set. So this is called many-to-one function. So this is many. From the definition itself, from the word itself, we can identify one-to-one means one to be connected to one. Many-to-one is many to one. Okay. Next one is on-to. So on-to is defined as if f is a function from A to B. If f is a function from A to B, the range and the codomain should be equal. So what is range? If an element is connected to the next set with some function, that is called range. Codomain is the set of all elements in the second set. That is called the codomain. That is, if you take this, the range and the codomain should be equal. So this is set A and set B. If you have elements like this, and here if you have elements like this, A, B, C, so the range and the codomain should be equal. So if you have like this, so all the elements in B, so this is the range is one element is connected to the other element with some function. So the range of this set is A, B, C, and codomain is also A, B, C. Okay, so the range and the codomain, if it is equal, then it is on-to function. Then into is if f is a function from A to B, when you have 2 sets A and B, there should be at least one element in B that does not have the image of A. That is 1, 2, 3, 4. Here A, B, C. When it is connected with a function, there should be at least one element that does not have the image. One element in B that does not have any image. So these are all the images we'll say. So this C does not have any image. Okay, so this type of function is called into function. So now based on these types of functions, we will be doing few sums. So already two sums I have completed in this exercise. Third sum is somewhat similar to the second sum, so you can do by yourself. Now I will do the fourth sum. So the fourth sum is show that the function f from n to n. So function is connected from natural numbers to unnatural numbers defined by f of x is equal to 2x minus 1 is 1 to 1 but not on to. So we are asked to show that the given function is 1 to 1 but not on to. What is 1 to 1? 1 to 1 is all the elements in A is connected to only one element. Okay, when it with some function, one element in A should be connected to only one element in B through some function. So that is called 1 to 1. On to is the range and the codomain values should be equal. So that is 1 to 1 and on to. So we will show this. We are asked to show that it is 1 to 1 but not on to. So first the function is defined as f of x is equal to 2x minus 1. So since it is given as natural numbers, we will take the numbers from 1. So f of 1 is equal to 2 into 1 minus 1. So 2 minus 1, that is equal to 1. 2 minus 1 is 1. Then f of 2 is equal to 2 into 2 minus 1. So 4 minus 1, 3. Then f of 3 is equal to 2 into 3. So 2 is constant here. X only should change. So x we have taken it as 3. So 2 into 3 minus 1. So this is 6 minus 1, that is 5. Then f of 4. So 2 into 4 minus 1. So 2 4s are 8 minus 1 is 7. So f of 5 is 2 into 5 minus 1 is equal to 10 minus 1, that is 9. So through this function, if we substitute f of 1 in the given defined function, we are getting these values. So now we will represent this in the arrow diagram. So the function is given from n to n. So this one is 1. Natural numbers to natural numbers. So both the sets have natural numbers. 6, 7, 8. Like that it will go. Okay. Same way on the other side also we are having natural numbers only. 6, 7, 8, 9. But when it is connected to the function, when it is connected to some function, if we take f of 1, that value is 1. So that function is given as 2x minus 1. Then f of 2 is equal to 3. So f of 2 is equal to 3. Then f of 3 is equal to 5. F of 3 is equal to 5. Then f of 4 is equal to 7. Then f of 5 is equal to 9. F of 5 is equal to 9. So we are asked to show that it is 1 to 1 but not on to. So from the arrow diagram, it is clear that one element has only one image in that. Okay, so one element is connected to the other element with a function with only one element. So this is 1 to 1, 2 to 3, 3 to 5, 4 to 7, 5 to 9. So this is 1 to 1 function. But it is not on to. Why it is not on to? The second set is called the second set. All the elements are called the codomain, and 1, 3, 5, 7, 9 are called the range. So codomain is all the natural numbers. So what are all the elements in that set is natural numbers. So that is codomain 7, 8. Then range is how it is connected to that function, connected to the previous element with some function, that is called the range. So what is the range we got? So 1, 3, 5, 7, 9. So range and the codomain are not equal. If it is equal only, we can say that as onto function. So since the codomain and the range are not equal, this function is not onto, but it is one to one. So we have shown that the given function is one to one but not onto. Next sum is show that the function defined from n to n by function from n to n, that is from natural number to natural number, defined by f of m is equal to m squared plus m plus 3 is one to one function. So the function is given as f of m is equal to m squared plus m plus 3. So n is the natural numbers from 1 to 3. So from 1 we take it as natural numbers. Okay, so here if m is equal to 1, then f of 1 is equal to 1 squared plus 1 plus 3. So we'll get it as 5. Then if m is equal to 2, f of 2 is equal to 2 squared plus 2 plus 3. So 2 squared is 4 plus 5, that is equal to 9. Then f of 3, that is if m value is 3, then 3 squared plus 3 plus 3. So 3 squared is 9 plus 6. So we get 15. Then m is equal to 4. F of 4 is equal to 4 squared plus 4 plus 3. So 4 4s are 16. 16 plus 7. So 16 plus 7 is 23. So like this it will be going on. Then the same thing, if we represent it in the arrow diagram, we are asked to show that it is one to one function. So both the sets have natural numbers from n to n. So from n to n. N to n. So when it is connected between the first element and the second element by some function. If 1 to 5 it is connected, only one element. So this is connected with some function. Then 2 to 9. So 2 to 9. Then 3 to 15. So 3 also can be connected. 12, 13, 14, 15. So 3 to 15. Then next one is 23. 16, 17, 18. All these are natural numbers. 21, 22, 23. So 4 to 23. So one element from the first set is connected to only one element in the second set. So this is one to one function. Okay. So with this I am completing today's class. Whatever doubts you have, you message me in the comment box. Thank you.